And part B is calculate the entropy, delta S, the change in entropy for this process, and using the Boltzmann approach. So, part B. We want to calculate delta S using the Ludwig-Boltzmann approach, and it is basically a statistical approach to it. And delta S is equal to KB times the natural log of, we're using W. In some texts they use omega to symbolize the number of microstates. Okay? And so, W is going to be proportional to some constant times the volume to Avogadro's number. The number of particles is going to appear in the exponent of the number of microstates. This is just some arbitrary constant which reflects the number of positions available for a molecule within a given volume. And the final volume, W initial, is going to be equal to 2 times is going to be twice the volume of the final volume, because we're compressing it into 1/2 its volume. So W final is equal to 2 CV, or I'm sorry, CV N naught. And therefore, delta is always what? Final minus initial. And so delta V, delta S is going to be equal to Boltzmann constant times natural log of omega final minus the natural log of omega initial. And what the rules of the exponents allow me to do here, when I have the distance between two, divide. Yeah, I'm going to divide. So delta S is equal to KB times the natural log of WF over WI, and that's equal to KB times natural log of CV over C2V, because we have twice as much volume compressing into 1/2 its initial volume, all taken to the N naught. So now the thing about this arbitrary constant and the volume itself, those drop out. And we're left with, this is equal to KB times the natural log of 1/2 N naught. Well, 1/2 is the same as the reciprocal of 2, right? Does everybody see that?
Mm-hmm.
Okay. Equals KB times the natural log of 2 to the minus N naught. And now the rules with exponents and the rules with logs allow me to pull any exponent through. I can go both ways. We did this a lot when we were deriving the law of mass action from the free energy. We were going the other way. So I can pull this through, and delta S is going to be equal to minus N naught times KB times natural log of 2. And now we just have to substitute in what is KB? What is Boltzmann's constant?
R over N naught.
It's the gas constant divided by Avogadro's number. So that's equal to okay? And now that drops out. I got another black pen, let me get a blue pen. So that drops out. To minus R natural log. Okay, so Actually, on the test, we don't have enough space for all of this. So a lot of the steps I put in here are extraneous. In other words, you could just simply state that the delta S is equal to the Boltzmann constant times the natural log of the final minus the O over the initial, and then go straight through.
Gotcha.
And we don't even need these many extraneous steps. I could start pulling things through immediately. I can get to this. I guess we could have these many steps. There's nothing for that. But you can use the key to the test as a guide. That has the essential information that should be included when you write our answer. Okay. So that handles